Chapter 2, Section 4 is about using derivatives to find absolute max and absolute min values. So it says suppose that some function f has a domain of I, then f of c, which is going to be an x input value, is going to be an absolute minimum if that y output at c is less than or equal to all of the other y outputs on that interval. So f of c is going to be a max if it's greater than or equal to all the other y outputs on that interval. So the extreme value theorem says that if I've got a continuous function f and it's defined over my closed interval beginning at a, ending at b, including the endpoints, that's what closed is, it must have an absolute max value and an absolute min value on the interval. So our max-min principle 1 says suppose that we've got this continuous function f defined at a closed interval from a to b. To find the absolute max and min values, we find the first derivative, we determine the critical values, we find our output values for the critical values and for the endpoints, and the largest of those will be your absolute max, and the smallest of those will be your absolute min. Your maximum minimum principle number 2 says suppose that you have a function f such that your derivative exists over the entire interval I, and that there is only one critical value c, such that your derivative is equal to 0. That means you have a horizontal line there, and that your output there in your original function will be an absolute maximum value if your second derivative is less than 0, because that means you would be concave down, so it has to be a max, or that your output value there is going to be a minimum value if your second derivative is greater than 0, because that means you're concave up, so you'd have to be a min.